We've now got ourselves down to just one test to review for. So I can go through 8 pages in a couple hours. They're not going to let Sean go on this, are they? Oh, well. Yeah, that's kind of what I felt. I didn't have a whole lot of sympathy. All right, starting in 5, 4, 3, 2. All right, let's go. Sparkplugs, wires, and servicing. I'm glad you're being a good sport about it there, Sean. 12 questions. Using too hot of a spark plug can cause. It will cause 2 things here, and it will prevent 2 things here. Ouch. Ouch. Oh, and I should have put blue in there. Remind me, I'll edit this. You will get a little bit more electrode wear. The biggest one is pre-ignition, because it gets too hot, it blows, and ignites the fuel air charge when it shouldn't. But too hot of a spark plug prevents carbon fouling, and it prevents lead fouling. Really hot, it gets clean. It's just, gets messed up. That makes sense? Only got half the class here. And that's a problem because this is related to a test question. Hot spark plugs cause pre-ignition. But using a hot spark plug is how you prevent carbon fouling and lead fouling. So what's going to happen to the temperature of my spark plug if we idle for a long time or we cruise around at low power in city traffic at like 30 kilometers an hour? Engine never gets hot. Spark plugs never get hot. What happens to them? Carbon fouling, yes. Flashover. What causes flashover? Where does flashover occur? Where in our ignition system do we get flashover? In the distributor, right. What causes flashover? When does it happen? And this is test questionable. In fact, I know there's test questions about this. It happens in the distributor. What evidence does it leave? Small lines, pencil lines, right. Okay. Pitting, not pitting. Pitting happens on the breaker points. Sumit, what does pitting on the breaker points indicate? What causes, I haven't answered that yet. What causes flashover? I'm waiting for you folks to tell me what causes flashover. Okay. Arcing. We've got 2 different places for arcing. Arcing on the breaker points leaves pitting on the breaker points. What causes, this is a different question, interviewer for a sec. What causes arcing on the breaker points? No. That causes flashover. What causes arcing on the breaker points? Failed capacitor. Thank you. Bad or failing capacitor causes arcing on the breaker points. Okay. And then Yedo, what causes flashover in the distributor? Low pressure. When do we get low pressure? High altitude. Thank you. Okay. So we've got two solutions to flashover. There's the old school solution, which is found mostly in museums now, and then there's the more modern solution. What's the old school solution, the original idea to solve flashover? What do we do to combat flashover at high altitude? There's two solutions. Low tension magneto, thank you. That is one method. That's old school. They're very rare. They work, but how many secondary coils do you need on a low tension magneto? One for each spark plug. So that means two for each cylinder. That's a lot. Right. We don't want to do that. Pressurized magnetos is the other. That's the more modern solution. Just pump air pressure from your turbocharger, because more aircraft, when they're going to high altitude, almost always have a turbocharger. One for each magneto and two for what? I don't quite understand your question, Interviewer. Two for each cylinder. One for each spark plug and two for each cylinder. One per plug, two per cylinder. Thanks. Yeah, we're on track there. Okay. So back to our Kahoot. Excessive idling or low power operation can cause carbon fouling. Might contribute to oil fouling if you got bad rings or something. But mostly it's going to cause carbon fouling because we don't get hot. We don't burn all of our fuel. You get some carbon smoke in there. Flashover, though, is not. In fact, flashover would never be a problem at idle and low power. We're at low altitude. We're not stressing the ignition system. We're really not going to have a problem with flashover at idle. Cold engine, yes. Cold engine temperatures could make it worse. Yes. Because spark plug temperature is obviously fairly closely related to engine temperature. Okay, I'm going to skip here because we have a lot of time left. Okay, long life, reduced maintenance, better heat dissipation. What does fine wire have to do with heat dissipation? Remember, our heat dissipation is entirely to do with this heat path. Is this a fine wire or a massive electrode spark plug, or do we care? Doesn't matter. It's all about that heat path. Okay. One point of confusion, I've had some students, when you read in the FAA, they say that fine wire gives a more efficient combustion. And this student interpreted to think that that meant that the spark plug would run hotter. That's not the case. Our heat range has got to do with how fast we cool the spark plug. Very, very little to do with the whether it's fine wires or massive electrode. So don't take that wrong path. Okay, so most of the class got this right. A few people got confused by better heat dissipation. I don't quite understand that. Is FADEC going to be on the test? All right. Have you done the review sheet? Yeah. You haven't done all the review sheet. I'm pretty sure we've got a comment on here that says, second to last page. Anyways, it says that they're not. So, did I miss it? FADEX systems, right here. Not covered in depth, and they are not on the test. Plus the fact that I haven't talked about them at all. It's kind of a hint too. Oh, wow. I said this like word for word. Remember our picture? Careless application of spark plug lubricant can cause. Oh, there we go. Right there. Careless application of lubricant can cause a permanently fouled plug. Right? There's my words. And then here is the Kahoot result. I don't know what to say. If you put too much thread lubricant on, you will not seize your spark plug. So, is there anything that was confusing? Yeah, if spark plugs stay in the engine for too long, they can get seized. But the most common like mechanics mistake that would cause a seized spark plug would be putting a long one in a short hole. And you are referring to, I'm pretty sure, this picture, right? Yep. If you use the long spark plug in here and you run it around for a while, you're going to get carbon to build up right in there into a big cakey mess. And then you'll try and get it out and you won't be able to get the spark plug out. That would be a bad thing. Oh, I didn't talk about this. I think I did a little bit, but not much. Right. It's got to do with the melting point. Platinum and iridium are expensive and high melting point metals. So that's worth noting. Platinum has a very high melting point. So does iridium, much higher than copper. The standard metals that spark plugs were built are normally made out of copper and steel. Right. Yes, you drop it again, or you can give it the float test, a popular test to see if spark plugs are good after being dropped. You put them, you throw them in the lake, and if they float, you can use them. And if they sink, you shouldn't, right? Yeah. It was similar to that old test they did for witches, where they put witches in a tub of water. If they sunk, they weren't witches, and if they floated and tried to swim, that proved that they were witches. So you can give them a float test. If they float, they're good. Mag drop. Mag drop. So we're going to go from both to the left. See how many RPM it drops. So we want to do it at 250 RPM, 700 RPM, 1500 RPM, or 2900 RPM. All right. Just taking a quick look at this. How many engines run at 250 RPM? None of ours, right? That isn't even a thing. Idle RPM. You could maybe pass off on that. 2900 RPM, that's like full power on our aircraft. We don't do anything at full power if we can avoid it. All right, good. And I said this several times. What do we really look for when we're checking our ignition leads? What are we mostly looking to check? The insulation. Because 20,000 volts, if my conductor isn't perfect, do you think 20,000 volts really cares? It's got a couple of ohms resistance. 20,000 volts is a freight train of electricity. And our biggest problem with 20,000 volts is not making sure it can get there. Our biggest problem with 20,000 volts is controlling where it goes, because it tends to go where it wants. It flashes over in the distributor, it jumps out through the insulation on the wiring. 20,000 volts is a lot of volts. So we're most concerned that the insulation is in good condition. We give a visual inspection for sharp bends, for any cracks. We want to make sure that water didn't get into the leads and start breaking down that insulation. But we are concerned about the insulation far more than the conductive core. That's perfectly normal. Remember, we went from 2 sparks per cylinder to 1. So you're going to see a little bit of a drop. If the left magneto timing was early, we wouldn't see any drop. If the left magneto timing was later than the right, we're probably going to see 100, 150 RPM drop. Do I need to go back to my picture on why? I don't, like, I lost half the class here, more than half the class. It's normal to see a 25 to 50 RPM drop when you lose a magneto. More than that, or less than that, in fact, we get concerned. Because if you see less than that, you're probably going to have a problem when you switch to the other magneto. I've tried to cover this in my class, kind of individually going through. Maybe we'll try and catch up tomorrow with Mr. Cliff's side, with the 378 side. Oh, good. Left magneto timing is incorrect. 25 to 50 is what we're expecting. We see more. We could be looking at bad timing. What are some other things that could be a cause of 150 RPM drop? One cylinder not firing. Okay, so if one cylinder is not firing, a fouled plug, a dead plug, sure. What else? Fouled lead. Leads don't get fouled, but they can break down. What part of the lead is most likely to have broken down? Or did you mean fouled with lead? Yeah, the insulator could have broken down, and that spark could be jumping to ground on the cylinder somewhere if there's a break in the insulation. Yeah, good answers. All right. When we go from both to left, if the left magneto was not firing, what would we see? The engine would die. Right. If the magneto timing was incorrect, a no RPM drop is actually indicative of a problem, because we should see a little bit of an RPM drop. So it's not normal operation either. We need to kind of work our heads around this one a little bit better, clearly. This is troubleshooting, and it's among the harder things that we to understand. It takes the deepest understanding of what's going on, and it's what we are paid the big bucks for. You know, a good troubleshooter is going to be in extremely high demand in aviation. If you can start to understand why things are misbehaving, you're going to be in very high demand. Shielded ignition wires versus unshielded. And I don't even think you could buy an unshielded ignition wire anymore. But if you could. All right. Shielded ignition wires cause capacitance after firing. They're the reason we get that. Unshielded ignition wires didn't have capacitance after firing. Shielded wires caused that problem. What's the solution to capacitance after firing? The resistor in the spark plug, right? We want the shielded ignition wire so that we can still listen to the hockey game while we're flying. Now, whether we should be doing that or that might, give us suicidal tendencies is another argument. But we want our radios to work, so we put in shielded ignition wires. That created this problems of this after firing, which wore out the plugs really quickly. So somebody came up with the slick idea of putting a resistor in the spark plug around 1500 ohms. $12 out of 12, nice. Magneto.